So in this recording, we're going to be looking at extending our understanding of expanding algebraic expressions. So again here, we're going to be applying our understanding of the distributive law to expanding algebraic expressions, including binomials, and we're going to still be collecting our like terms where it's appropriate to do so. So in order for us to be able to effectively go in and expand more complicated expressions, we need to make sure that our understanding of the distributive law is quite concrete. Now, I have made mention of the word binomial, and I just want you to understand that a binomial is an algebraic expression that involves two terms, hence the term binomial. So let's look at applying the distributive law using what we call the area model. So we're going to be applying our understanding of finding the area of a shape in order to help us to expand the expression x plus 3 times x plus 5, and then simplify that as well. So let's actually label this particular rectangle here. So we've got our binomial expression in that it's got two terms. So the first being x plus 3. So I'm going to write that here. So I'm going to make this have a length of x plus 3. And then I'm going to make the top and the bottom have a length of x plus 5. So now, if I had asked you to find the area of this particular shape, you would basically multiply this length here, so let's call that the width, and you would multiply that with the length, x plus 5. So the area would be length times width, which would translate to x plus 3 times x plus 5. Now you can see here that this is the equation or the expression, that we're asked to expand and simplify. So let's split this up even further. So now let's move on to this particular rectangle here. Now, what I want you to notice, it's exactly the same rectangle, only you can see that I've split it up into 4 little shapes. So think about what we talked about when we were finding the area of composite shapes. And in order to find the total area, we would find the area of each shape within that big shape and add them all together. So we're going to apply that concept to this here. So we made the length be x plus 5. So what I'm going to do here is now split up this into each square and rectangle. So I'm just going to start by labeling each of these. So 1, 2, 3, and 4. So I'm going to make this bit here have a length of x, which means my remainder is going to be plus 5. So then moving to my width, I'm going to make this here have a length of x, and this here have a length of positive 3. Now what you see here is that means the total length is going to be x plus 5, and the total width will be x plus 3. So we haven't actually changed the original equation by any means. All we've done is we've split it up into smaller and more manageable shapes. So now let's find the area of square number 1. So the area would be x times x, which simplifies to x squared. Then the area of shape number 2, which is a rectangle. So this here is 5, and this length here is going to be x. So 5 times the x will give us a total area of 5x. Moving on to shape number 3, so we have the length here of 3, and the bottom will have a length of x. So the area of this will be 3 times x, which equates to 3x for a total area. And then for shape number 4, we know this here has a length of 3, and we know that has a length of positive 5. So finding the area of that, we'd do 3 times the 5, and that will give us a total area of 15. Now we need to find the total area of this particular rectangle. So what we're going to do now is we're going to So what I've written here is that now we're going to combine through addition the areas of each of the numbered shapes together and then simplifying the expression that results from that. So let's have a go at writing it down. So I'm just going to highlight what each of the areas were. So now writing them all together, we end up with x squared plus 5x plus 3x plus 15. Now looking at this expression here, we can see a like term. So 5x plus 3x can be simplified, leaving us with a final answer of x squared plus 8x plus 15. And that's how we would expand the expression x plus 3 times x plus 5 using the area model. So let's have a go at doing this again for another particular question. So here you can see I've asked you to expand and simplify the expression x minus 2 times x plus 3 using the area model. So let's start by labeling our sides. So I'm going to make this be x minus 2, and I'm going to make this be x plus 3. So now obviously from here we do need to do a little bit more work. So I would encourage you to then split this rectangle into three smaller rectangles and one square. So now I'm going to label each of these. So I'm going to label this x and this -2, remembering that in the original shape, that length there was x minus 2. Then for the side length, the total length was x plus 3. So splitting this up now, I'm going to make this part of the rectangle x and this bottom length here be positive 3. So I'm just going to draw smaller arrows so it's clearer what length is associated with what part of the triangle, the rectangle or the square. Alright, so now what we're going to do is find the area of each of the shapes inside this rectangle. So finding the area of shape 1 would be x times x for a total area of x squared. Then here, keep in mind that we have that negative, and that's really important because that is going to change our value. So here we're going to have a equals to -2 times x. Simplifying this now, we get -2x for the area of rectangle number 2. Then with rectangle number 3, let's find the area of this. So area is, keeping in mind that's x times positive 3, giving us a total area of 3x. And then last but not least, rectangle number 4. So it has dimensions of 3 times -2 for a total area of -6. So now to combine all of them together to find the total area of this rectangle, we would do x squared minus 2x plus 3x minus 6. So now simplifying our like terms, as you can see I've highlighted that -2x plus 3x are like terms. So I'm going to get x squared plus x minus 6. So now let's have a go at expanding the exact same expressions, except this time we won't use the area model. We'll call it the FOIL method that we're going to apply. So with the answers that we get for 1 and 2, they should be exactly the same as the solutions that we found using the area model. So recall that we got x squared plus 8x plus 15 for the first equation. So let's use our understanding of algebra and with no diagrams and have a go at expanding this exact same expression. So the first thing I'm going to do is I'm going to multiply my x value here with that x. So I'm going to get x times x, then multiplying that x with the positive 5. So I'm going to have 5 times x. Then moving on to the positive 3, so I'm going to multiply 3 times x So positive 3 times x, and then 3 times 5. So now simplifying my terms together first using multiplication. So x times x is going to give me x squared. 5 times x is going to give me 5x. 3 times x is going to give me 3x. And 3 times 15 is going to give me 15. So what you can see here is that we've already simplified the expression. Now looking at this, we can simplify it even further because we do have like terms there in the middle. So term 2 and 3 are like terms. So simplifying that further, we get x squared plus 8x plus 15. Now let's check and see whether this was our answer when we use the area model. So we can see here we got x squared plus 8x plus 15 using the area model, and that is the exact same answer we got using FOIL instead of the area method. So what I want to show you here is that we can use a diagram with helping us to expand expressions, and sometimes it is just easier to have that rectangle and apply your understanding of geometry with adding shapes to help you to expand an algebraic expression. All right, so last but not least, let's do the next question. So here we've got x minus 2 times x plus 3. So again, starting with our x's, so x times x is going to give us x squared. Then x times positive 3 is going to give us 3x. Then negative 2 times x is going to give us minus 2x. And then negative 2 times positive 3 is going to give us negative 6. Again, make sure you scan your expressions for any like terms. And what we can see here is that we've got a like term at 3x minus 2x. So simplifying that further, I'm going to get x squared plus x minus 6. Now let's check and see whether that was the same answer that we got using the area model. Scrolling up, we can see that it was. So once again, you can see here that whether you use the area model or the FOIL method to help you expand the expression, you'll get the exact same result. If you are struggling a little bit with working through the FOIL method without a diagram, I would encourage you to use the area model to help you with expanding binomial expressions, because as you can see, we can achieve the exact same result using the area method that we do if we use the algebraic method of FOIL.